Hello everyone, welcome back to the channel The DevOps Bucket. So in this video we are going to deeply understand how IRSA works in AWS, and we will see why IRSA exists and how OIDC works, what happens exactly when you use this in your EKS pod. By the end of this video you should able to explain IRSA confidently in interviews and design discussions. Let's start from the problem that IRSA was designed to solve. When we run Kubernetes workloads on AWS EKS, our pods often needs to talk to the AWS services like S3, DynamoDB, SQS, STS, etc. For example, a backend pod, okay, let's say there is one backend pod which may need to read objects from S3 from EKS pod if you want to connect to the S3 or to and push the messages to SQS or read the messages from SQS. You want to access the other services from your application that is deployed as a pod. Initially, we require a role or a permissions for our pod to do these actions, right? So initially AWS solved this by attaching an IAM role directly to the EC2 worker node. When with EKS cluster we will have the worker nodes, right? So we will directly attach the IAM role to the worker node role, right? This node role was used by every pod running on that node, okay, to do these actions. While this approach works fine, but it creates a serious security issue sometimes because every pod on that node get the same permissions. Let's say your deployment pod, let's say backend pod, want to communicate to the S3 bucket. In that node there are few other pods that are running as well, which will inherit the entire permission scope which you attached at the node level, right? So that will become a break for a least privilege access and increase the blast radius if pod is compromised. So the IRSA was introduced to solve this problem by allowing a IAM role to be associated directly to the service account that your pod will uses instead of the EC2 nodes. So what will happen here? You will create a separate IAM role instead of relying on EC2 role with a service account in the Kubernetes cluster. This is what IRSA solves the problem. Now let's understand what is IRSA. So IRSA stands for IAM role for service account. So IRSA means IAM role for service account. It actually allows a Kubernetes service account to assume a specific IAM role. That IAM role is trusted, but not because of EC2 instance or a node role. Okay, but it's a separate role that we are using. Kubernetes itself proves the identity of the pod using some signed tokens that we are now discussing further. Okay, so to do this signed token type of authentication, we require one concept called OIDC. OIDC. OIDC is basically Open ID Connect. OIDC is basically an authentication protocol. Okay, basically it's an authentication protocol which was sits on top of another framework called OAuth 2.0. Okay, this is an authorization methodology protocol. The OIDC basically an authentication protocol which sits on top of this OAuth 2.0. This OAuth 2.0 actually handles an authorization, like what user can do. OIDC here adds an additional layer to OAuth 2.0, like authorization part, and it adds in one more layer on top of it called an authentication via tokens. I hope you know authentication and authorization. Authentication means who the user is coming to my system. That is the authentication, like whether I approve or not to log in or to go inside our system. Authorization is basically providing a permissions what to access for that particular user. Whenever a user comes in, authentication stops him and asks that authenticate yourself, show me your Aadhaar card or ID card. Okay, so once that ID card has been approved, then it will go inside, and on the premises what operations you can do, that is authorization principle. So here OIDC is basically an authentication at first, but it sits on top of OAuth 2.0, so it combines authentication and authorization by a token system. Okay, this is about OIDC. In the context of IRSA, EKS act as an OIDC identity provider. Okay, so the OIDC, as I said, the OIDC is basically allows one system to issue identity tokens and another system to verify them and allow them to do the actions. Here in our EKS cluster, which our cluster itself, EKS itself act as an OIDC identity provider, and AWS IAM that we created a role as separately that will another system which will be verifying that particular connection that is coming from the OIDC. EKS cluster has an OIDC URL. This URL represents Kubernetes API server's identity system. AWS actually exposes public keys at this endpoint so that IAM can verify the tokens issued by the cluster. So IRSA is basically uses an OIDC identity provider, which EKS will be act as in that position, and AWS IAM, that this is the role that we have created, act as a relying party that trusts the identity coming from that provider. As simple as that. Okay. And now let's walk through the full workflow starting from the cluster setup and ending with a pod calling an AWS API. First, when we create an EKS cluster, let me show you one EKS cluster I have already created. Okay, when you create an EKS cluster, AWS EKS will automatically creates one OpenID connection provider for you. Okay, AWS automatically creates it. This endpoint is unique and represents identity system of your Kubernetes control plane. This will be unique for every cluster. As I said, EKS will by default creates this particular URL. What we need to do, we need to tell the IAM service that this is my cluster's OIDC provider URL. Please keep eye on it. Whenever any request coming to this from this OIDC provider, please accept that. To make that happen, we need to link this particular OIDC URL to the IAM. How to do that? Let's go to the IAM console, and in the left hand side you have identity providers here. Click on the identity providers. Here you need to click on add provider and OpenID connect, and you need to paste our OpenID, whatever the URL that EKS has provided to you, just add it here. And audience should be an AWS STS, because STS is basically is a simple token service which will provide us the temporary tokens once the authentication happened via this token service by OIDC. Further, once we link this, we will create an IAM role. This role actually not trust any of EC2. Instead, it uses a trust policy which allow the AWS STS service to assume this role only when the request coming from this OIDC provider. Okay, inside the trust policy, we will define the conditions like the when your request is coming from the namespace and the service account, then only you will verify them, otherwise you can ignore. Okay, after that you will create a service account in a Kubernetes cluster. The service account has been created. Annotate that particular role that we are created in AWS console in that particular annotation. This is annotation is the logic link between Kubernetes and IAM. Okay, first let me link it. Okay, STS Amazon aws.com. This is the audience. Okay, just click on add provider. Okay, once click on add provider, it will ask you to assign a role. Okay, click on the assign role and click on create a new role. Once you go here it will ask you for the audience and click on next. Okay, here let me put some EBS CSI driver policy, which I explained this in my previous videos where I used this IRSA for EFS volume creation and EBS volume creation. If you haven't watched that, please watch it after this video. Okay, test role, let me put that role name as test role. If you see the trust policy, right, so what it is saying, action is STS assume role web identity, and whenever the principal, the connectivity is coming from this principal, this is our OIDC sure URL. Okay, once if you see this unique ID is matching with our cluster's unique ID, see, right? So this is what is unique per cluster. Okay, you need to add this particular thing in our trust policy so that we are saying to IAM that please accept whenever the connectivity or request coming from this principal. And conditions, I am talking about this, right? So conditions we have to mention to which audience it should listen to, and we can also add one more condition here called subject. What is that subject? Here we are using audience. If we want to add one more condition, we can use subject by mentioning the service account and the namespace. By default in this trust policy it will work for all namespaces and all service accounts whatever we have annotated. Okay, so that's it, and we will create a role. Now let's see what happens in the runtime when a pod actually starts making a request. Okay, so we have already created a service account and annotated this IAM role in that service account. Now when a pod is created using this service account, right, when a pod is created using this service account, the Kubernetes automatically mounts a projected volume inside the pod. This volume contains a token. That token is basically called a JWT token, JSON Web Token. This token is signed by the Kubernetes API server and includes the claims such as namespace name, service account name, and the OIDC issuer URL. Okay, so this JSON token will contain the information about service account, namespace, and the OIDC issuer URL. Okay, then the token is short-lived and is rotated automatically by the Kubernetes only. The pod does not store any credentials or any AWS credentials. It has only this identity token, which will be mounted as a volume by whenever you create a service account. Okay, now suppose your application inside the pod want to access the S3. The AWS SDK, which was the using by your application, will is a IRSA aware. Your application will look for the node role, IRSA, pod identity, anything it will look for. By default, it will look for the node role. If you have mentioned to look for IRSA, there will be SDK an option to implement that. Okay, then instead of looking for access keys or a node role, it will detect the IRSA running inside the EKS cluster as our service account. Then the SDK reads this web identity token that is mounted in a particular pod wherever the service account is using, and it sends a request to the AWS STS by calling an API called assume role with web identity. So if you see here in the trust policy, we are we are only allowing the action called STS assume role with web identity. So your SDK, which is assume, which is have the token now, web JWT token now, will call this API to get an STS tokens. Okay, along with that request, pod sends the OIDC token and the IAM role ARN. Okay, whatever we have annotated in our service account. Now this is important part happens inside the AWS. Let's see that. AWS STS receives this request, and first it validates the token signature. It does this by actually fetching the public keys from the OIDC EKS issuer endpoint. If signature is valid, AWS knows the token issued by your cluster. Next, if not, then it will ignore that request. Next, AWS checks the IAM roles trust policy. It verifies the token claim matches with the conditions defined in the role, such as a namespace or a service account name and the federated identity, whatever it coming from. If everything matches, AWS STS issues a temporary security credentials. These credentials includes an access key, secret key, and session token. They are valid only for a short duration. These credentials are returned to the pod via SDK and cached in the memory. Now, only the pod can call the AWS services like S3 or DynamoDB, SQS, etc. Every API call is made by the pod is signed using these temporary credentials. AWS services validate the signature and checks the IAM policy attached to the role. If the policy allows that action, request succeeded. When the credential expires, right, the SDK automatically repeat the process. A new token is issued, STS is called again, and fresh credentials are issued. No manual rotation is required, and no secrets are stored in the Kubernetes cluster. So, if we want to summarize this particular identity chain in simple words, pod proves its identity through the Kubernetes. Kubernetes proves the pod's identity to the AWS using OIDC. AWS STS verifies the identity and issues the temporary credentials. Then pod can able to assume them and do the actions like S3, SQS, or etc. Here there is no node role involved or no other roles are involved. Only whatever the role that we have created separately will involve. The other pods will not able to access this. Only whenever you are using that service account with the pod, then only it will work. Okay, this actually gives us the strong isolation, least privilege access. So let me just summarize you the quick steps. First we create an EKS cluster. It will give you a OIDC issuer URL. Then we'll link with the IAM identity providers. You will assign role to that by providing this trust policy. Actions is STS role with assume role identity with STS assume role with web identity, and then the conditions whatever you want. You want to restrict to the particular namespace and service account, or otherwise you want to allow for every class for all the cluster components whatever the service account is part of. Okay, and then when you will go to the EKS cluster and in the CLI and create a one service account, add the annotation with this role ARN. Once this role ARN everything annotation has been there, and you will give this IRSA details to your SDK. SDK will call the STS assume role web identity with the token that get by the OIDC IRSA process, which will be mounted as a volume to the pod. Once it get the token, it contains the OIDC issuer URL, session namespace, service name, and everything details, and it will call the STS service to verify it. So STS comes to this, and it will identify what are the requests coming from where the request is coming from, matching with the trust policy, and we will trust it. And then it will go to the AWS STS service and provides the temporary credentials, and those temporary credentials will be given to the pod. And the SDK will assume them and do the necessary actions, and after that it will store in the cache until this particular time. As it is short-lived duration, it will be worked until the those are active, otherwise it will do the same operation again. So this is the OIDC and the IRSA concept in the AWS EKS, which will be very helpful. And in the further videos, I will be explaining you very clearly about pod identity agent, what is the difference between pod identity and IRSA. So till now, I hope you understand everything. If you confused at any part, or if you have any questions, or you want me to showcase any of the use case on top of it, please comment it down below. I will try to explain everything about whatever questions you have. Thank you. Have a great day. Thanks.